All right, guys, tomorrow is quiz number 1. There's no reason for you to be nervous, all right? It's 10 questions. If you want to write that down, feel free. It's 10 questions. They're all free response. So remember, the more work you can show me, the more credit that I can give you guys. Tomorrow, I will not be answering any questions after 7:55. If you have something quick in the morning, you want to come, that's fine. But after that, I'm not answering, especially in between classes, after you've talked to other people, no questions. Definitely no questions during the quiz. Everything's self-explanatory. I have pencils in my little pencil dispenser. I have a sharpener. I have erasers. You guys don't need anything. I'll give you the quiz to write on. We do it on paper. But it's 10 questions. Anything that you have seen on homework, in notes, anything we've gone over is fair game. Right? We're not going to go through a review that's like you're going to have one exactly like this and then exactly like this. You have to be able to apply the stuff that we've learned. How to multiply same bases, how to divide, power to a power, negative exponents, all that kind of stuff. It's very basic, guys. Very basic. Nothing to try to throw you off. Just you've got to know what you're doing. And it's important that we work in a timely manner because you only have 30 minutes. You don't have the whole class period. So we got to make sure that we know what we're doing. So let's just go through here. This is both the reviews that are there. I kind of pulled problems from each. I'm not doing every single one. The solutions are there. You're welcome to look at. And then I think I have 2 at the end that I just made up. Simplify and write with positive exponents. All right. In a case like this, what is the first thing I need to do? Distribute. Perfect. We're going to distribute, remember, to everything. Everything first. So this becomes negative x squared y squared, z to the what? Z to the 4th. Power to a power, we multiply. Good. And then this becomes x squared, y to the 4th, correct? You guys agree? All right, what is negative x squared? Negative x times negative x is x squared, good. Then I have y squared, z to the 4th. And then here I have x squared, y to the 4th. This is a multiplication problem. If we were adding, we would not be able to go any further. But we're not adding, we're multiplying, correct? So when we multiply same bases, what do we do to the exponents? We add. So I'm going to rewrite my x, and then I have 2 plus 2 is what? 4. Perfect. Now I have my y's. I rewrite my y. 2 plus 4 is what? 6. And then what do I write down? Z to the 4th. And I circle my answer and I move on. All right. Tomorrow there will be an answer line. If you don't want to put your answer on the answer line, I don't care. Just circle it. I'm really good about finding things, but just circle so I can see where you want me to look. If you don't write it on the line, not a big deal. All right. Next question. It says to rewrite with positive exponents. We want to simplify. Again, if you guys want to go ahead and do your subtraction and stuff like that because we're dividing same bases, that's fine. I personally am going to fix my negative exponents. Anything that's negative, an exponent, you want to move it. So I'm going to take y to the negative 3/4 and move it down. And I'm going to take y to the negative 1/2 and move it up. If you do not want to do that first, you don't have to. I'm just telling you how I like to do it. So I have x to the 1/3, y to the 1/2, over x to the 2/9, y to the 3/4. Everybody with me? You guys agree? Okay. So now if we have the same bases, y'all, and we are dividing, what do we do to our exponents? Subtract. So I'm going to rewrite. I have x to the 1/3 minus 2/9. And just down here, I'm going to say y to the 1/2 minus 3/4. How do we subtract fractions? You have to have a what? Common denominator. Okay, what's our common denominator for my x's between 3 and 9? 9. So if I multiply the bottom by 3, I have to multiply the top by 3. You guys agree? So this becomes 3/9. So 3/9 minus 2/9 is 1/9. Good. And then same thing for my y's. How do I need a common what? Denominator. What's the common denominator between 2 and 4? So if I multiply the bottom by 2, then the top. So I have y to the what? Negative 1/4. The directions explicitly say to write with positive exponents. So how would I rewrite this? Tell me. y to the negative 1/4 goes where? To the bottom. So we have x to the 1/9 over y to the 1/4. And you can leave it like that because you can't simplify anymore. It's not a number, so just leave it. Questions? Talk to me as we go if you guys have questions. And again, I'm recording, so you can go back and watch this. I just want to make sure I get through everything. Now, this is from the other review. I copied and pasted. Yes, ma'am. Yes, if it were to have a number that you could simplify, then yes, go ahead. Yes, you would simplify it, yeah. All right, guys, what's going on in this problem? Look at this problem. You're going to have one similar to this on your quiz. What is going on between these two terms? What's that sign? Yeah.
Where'd you get that equation?
It's from the other review. Hmm? It's on the other one. I just pulled from both. What sign is in between these two? Parentheses. Addition. When you, at the end, in order to add, what do you have to have to make sure that you can add them together? Same variable, same exponents. Make sure you guys see this. So what do I have to do first? Distribute the 2. Okay, so the 2 is going here, here, and here. So I have 4 squared x to the what? 4th y squared plus negative 3x to the 4th y squared. What is 4 squared? 16. Guys, I am no longer multiplying. What am I doing with this and this? Adding, or if you want to say subtracting, you can. Can you combine these two? Do they both have the exact same exponents on x and y? Yes. So I have 16 minus 3. What's my total? I have 13. And what happens to my x's and my y's? I write x to the 4th y squared. You do not add exponents at that point. We only add exponents when we're multiplying the same base. When you're just adding and subtracting, the last name stays the same. That's a very common mistake that you guys might make. If you make that x to the 8th, y to the 4th, that's a lot of points off because you don't understand that when you're combining like terms, you do not add the exponents. Little things like that we really got to pay attention to. All right, this is another one from the other review. What's going on between these two parentheses? Multiplication. Very good. It's different from the one above, so just make sure you're paying attention to that. What do I have to do first? Distribute. Very good. I'm going to keep saying the same thing over and over. So I have negative 3xy squared times 4 squared x squared y to the 4th. Everybody with me? Okay. Good, good, good. So let's simplify a little bit more. Negative 3xy squared times, what's 4 squared? 16 x squared y to the 4th. Now again, guys, are we adding here? No, we are multiplying. So we're going to take our coefficients. What is negative 3 times 16? Perfect, negative 48. Now when I'm multiplying same bases, what do I do to the exponents? Add. Remind yourself there's a 1 there, so we don't make any silly mistakes. So I rewrite my x, and it's x to the what? 3rd. 1 plus 2 is 3. Good. Then I rewrite my y, and 2 plus 4 is awesome. Very good, guys. Do you see the difference in these two problems? Make sure you are just paying attention. Everybody in here can do that, no problem. Just make sure you're paying attention. All right, same kind of problem. I want to make sure we see. What are we doing here? Multiplying or adding? Do we see any addition signs? No. So what do I have to do first? Distribute. Very good. I'm going to distribute to everything. So I have negative 2 squared x squared y to the 4th. Everybody agree? Times negative x squared squared. And y to the what? 4th. What's negative 2 squared? 4. So 4x squared y to the 4th. What's negative x? What's this going to be? X what? X to the fourth. Y to the fourth. Power to a power, we multiply. So then I take my coefficients and I say 4 times 1 is 4. Since I am multiplying same bases, I rewrite my base and do what to my exponents? Good. So I have 6 and then y to the 8th. Great job. Great job. All right, I know I'm going quickly. I just want to make sure I hit everything. All right, you definitely will have something like this. What's the immediate problem you see? Radical in the denominator. Should we just multiply the top and bottom by the square root of 28? No, if you do that, you're going to spend 15 minutes trying to multiply 28 times 14 and break it down. Don't do that. Since they're both underneath a radical, can't we do this? What can I break 14 into? 7 times 2. Okay. What can I break 28 into? 7 times 4. Does this make our life much easier? If I have the same number underneath a radical in the numerator and denominator, what can I do? I can cancel. So my 7s cancel. Does anybody know what the square root of 4 is? It is 2. So what does our problem become? 3 square root of 2 over 2. Much easier than trying to rationalize first. Can I, guys, am I allowed to say, oh, this 2 cancels with this one? No, you absolutely cannot, because the square root of 2 is a very different number than the whole number 2. So just make sure you guys are aware of that. Always try to simplify first. All right, scooting along. All right, how is this one a little bit different from the one we just did? Correct. Is there something attached to that square root of 14? Yes. You cannot just multiply the top and bottom by square root of 14. We need the radical to disappear. What am I going to multiply the bottom by in order for my radical to disappear? The conjugate, the opposite. What is the opposite or conjugate of 3 plus radical 14? Very good, guys. What you do to the bottom, you do where? Perfect. I said yesterday, I think it's best to deal with the denominator first, just to make sure you got your sign right and that your radical disappears, right? So let's FOIL. What is 3 times 3? 9. 3 times negative square root of 14? Minus 3 square root of 14. Perfect. What's the square root of 14 times positive 3? Plus 3 square root of 14. Awesome. And then what's a positive square root of 14 and a negative square root of 14? Yes, it's the 196, right? Which is, square root of 196 is 14. All right, so this is minus 14. What happens to my radicals in the middle? They do cancel. Isn't that what we wanted to happen? So I'm left with 9 minus 14. What's 9 minus 14? Negative 5. We wanted the radical to cancel. Did it? Yes, mission accomplished. So now let's just FOIL the top. What's 1 times 3? 3. 1 times negative root 14 minus the square root of 14. What is the square root of 7 times 3? All right, so I'm sorry. Again, what is the square root of 7 times 3? We just write 3 square roots of 7, right? And then what's the square root of 7 and negative square root of 14? Do it. Write down 14 times 7 and do it. 98. Thank you. Now, guys, a lot of times when we rationalize, we do this, we can combine stuff in the middle. In this case, does anything combine in the middle? No. So what you end up with is 3 minus the square root of 14 plus 3 square roots of 7 minus the square root of 98 all over negative 5. All right. Now, there is a little that you could simplify here. What else could we simplify? Is there a perfect square inside of 98? What's 49 times 2? 49 times 2 is 98. So this would actually simplify minus 7 square root of 2 all over negative 5. If you did not simplify that, I don't even know if we would take anything off. Maybe a point. I don't think it's that major of a deal. I don't know if something like that will arise, but just look for anything that's hidden square roots. But guys, look at this. This is a mess up here, isn't it? But can you combine anything? How come you can't combine any of those radicals? None of them have the quote-unquote same last name. They don't have the same radicals, so they're not going to combine. All right? That's a bit of a messy problem. Again, I'm not telling you how to do your problems. If you want to go through and do all the ones that you think are super easy, do that first. You want to start with the one that you think is the hardest, do that first. Whatever works. Yeah. Simplify and write with positive exponents. What do I think is the best way to attack this problem? Get rid of the negatives. I'm going to circle this one, and I know this needs to go down. I'm going to circle this, and this needs to go where? Up. So I'm just going to simply rewrite. My numerator is 3x squared, z squared, z to the 4th. You guys agree? Let me know if I missed something. I know I'm trying to go quickly. So at the bottom here, I have 4x, y to the 3rd, y to the 1st. Did I get everything? Okay, perfect. So now that we have all of our exponents positive, let's deal with it. 3 and 4. Nothing's going to simplify, so I'm just going to rewrite it. I have 2 x's on the top and 1 x on the bottom. When I am dividing same bases, what do I do to the exponents? Subtract. So I have x to the 2 minus 1. You guys agree? So where's my x going to be? In the numerator in the top. Good. Then I'm going to go in alphabetical order. I have my y's. I have 2 y's on the bottom that I'm multiplying. If I'm multiplying same bases, I rewrite the base and do what to the exponents? Add. 3 plus 1 is perfect. And then I have z's. I have 2 z's that are on the top. One of them has an exponent of 2. One has an exponent of 4. When I multiply same base, I do what? Perfect. Perfect, perfect, perfect. Good job, guys. Again, here's another one of those problems. You guys are seeing this again. You're going to see this on your quiz. There's 2 different things going on here. We are multiplying, and then we're doing what? Adding. Remember, when you add, you have to have the same exponents on each variable. So the first thing I'm going to do is go ahead and distribute everything. So I have 3 squared, x to the 4th, y to the 8th. Good. Power to a power, we multiply. Then I have plus. I'm multiplying these 2 together, so take your coefficients. What's 2 times negative 1? Negative 2. Multiplying same bases, so I rewrite the base and do what to the exponents? Add, so 1 plus 3 is 4. Again, multiplying same base, rewrite the base, add the exponents. 2 plus 6 is 8. Very good. Let's go ahead and simplify 3 squared. 9. Can I add these 2 together? I have 9 x to the 4th y to the 8th minus 2 x to the 4th y to the 8th. So what's 9 minus 2? 7. And what do my variables look like? What do they say? X to the 4th, y to the 8th. We only add exponents when we're multiplying. When you're adding and subtracting, they stay the same. All right, a question like this where we have to simplify. We want to break down to the biggest perfect square, smallest non-perfect square, yes? So let's keep that 4 on the outside. What can I break 63 into? 9 times 7. Perfect. What is the square root of 9? I take out the 3. What do I do to the 3 and the 4? Multiply. So 3 times 4 is 12, square root of 7. That's it. Don't make things harder than they need to be. Good job, guys. Another one of these problems. You guys keep seeing these. All right. Are we adding it all here? Are we adding it all? No, there's no addition. So we need to distribute, multiply, and what did the directions say? Simplify and what? Positive exponents only. So let's distribute first. I go here, here, and here. So this leaves me with 4 squared x to the negative 2, y squared, correct? Times 8 squared, x squared, y to the what? Negative 4th, okay? I'm going to transfer over here. Let's go ahead and simplify. What is 4 squared? 16. And what is 8 squared? 64, okay? So we're going to have to multiply two big numbers. Can we handle it? We can? All right, 16 times 64. So 1,024, right? Now we're multiplying, so I'm going to rewrite my x, and I have x to the negative 2, and I have x squared, correct? I rewrite my base, and I add my exponents. What's negative 2 plus 2? Okay, x to the 0. And then I'm going to do the same thing with my y's. I have y, and I'm going to add my exponents. What is 2 plus negative 4? Negative 2. I have to rewrite this using positive exponents only. So remember, this is over 1, correct? So where am I going to move my y to the negative 2? To the denominator. Can I leave x to the 0 power like that? If you want to, you can. I don't. It's fine. But what is x to the 0 power? 1. You just cross it off. If you left it as x to the 0 power, I'd be fine with that. If you left it as just x, no. Because what is just x to what power? 1. To the first. If you leave it as x to the 0, I understand that you subtracted your exponents and you know that it's 1. But if you leave it as just an x, that's super wrong. So how would I rewrite this? 1,024 over what? Y squared. Now, some of you might have gone about that a different way, which is totally fine. Some of you might have rewritten it with the x on the bottom, x on the top, and then you realize they canceled. That's fine. Just as long as you show me what you're doing, we're good. All right, another one of these playing with our negative exponents. Again, I like to move first, so I'm going to remind myself that this goes down. This one comes up. This one goes down. And this one comes up. Hang on one sec. I think it might be from the other. Yeah. Number 11. All right, so I'm going to rewrite 14 x to the 4th, y to the 3rd, over 16 x squared, y to the 3rd. Everybody agree? All right, now that all my exponents are positive, we're just going to go ahead and simplify. What number goes into both 14 and 16? 2, right? So my 14 becomes a 7, and my 16 becomes 8. Good. I'm dividing same bases, so what do I do to the exponents? Subtract. So it's x to the 4 minus 2. So that leaves me with what? X squared, okay. So I have 7 over 8. Where is the x squared? On top, good. And then I have y to the 3rd divided by y to the 3rd. What happens there? They just cancel. If I say y to the 3 minus 3 and get 0, you get y to the 0 power. That's just 1. You could write y to the 0, but you cannot write just y.
Isn't it x to the 2nd power?
What did I write for? I'm not sure. Thank you. This is squared, right? Yes? Okay, just making sure. Keep me on my toes. You have to. All right. Again, should we multiply top and bottom by the square root of 10? No. Nobody wants to work with 720 and try and break that down. Let's simplify how we can. What is a perfect square and a non-perfect square that I break 72 into? 9 times 8, okay. And what about 10? 2 and 5. What's another way we could have gone about that? Because we're going to break down 8 again, right? What are we going to break down 8 into? 2 and 4, okay. What's another way we could have broken this down? I want to go with how you guys are thinking. What's another thing we could have done? 36 and what? 2, okay. Does that help us a lot? Yep. What's another thing we could have done? from the beginning? What can we do with 72 and 10? We could reduce that, couldn't we? What's 72 divided by 2? This would be 36. And then what's 10 divided by 2? 5. Because look, guys, we're going to get to the same place anyways. Because if I have a 2 on the top here and a 2 on the bottom, I can cancel them out. There's a million different ways you can do the same problem. I don't care as long as mathematically it makes sense. So as we continue to simplify in the top, guys, what is the square root of 36? This becomes 6. And then I multiply 5 times 6 and I get what? So I have 30 over the square root of 5. Again, there's a bunch of different ways you could have gotten there. Try to go the easiest route. Yes, I understand that 72 is 9 and 8, but try to find the biggest perfect square. Or, from the get-go, simplify underneath whatever's in the radicals. Whichever works for you. But now, what do? Multiply top and bottom by radical 5. Perfect. So this becomes in the numerator what? 30 square root of 5 over 5. Am I done? Why not? I can simplify on the outside. 5 goes into 5 once, and 5 goes into 36. So what is my actual answer? 6 square root of 5. Now again, if you don't get all the way there, that's fine. You only get a couple points off if you show me your work. You want to simplify completely as much as possible. All right, let's pay attention to 13. 13 is really important. Is the negative included in this problem? No, it is not. That's a negative that's on the out. If the problem was written like this, that means, oh, I'm talking about negative 144. That's not what this says. The first thing I want you to do is recognize that this is a negative exponent, right? So how do I rewrite this? Nope. Fix the negative exponent first. 1 over, thank you. What? Negative 144 to the 3 over 2. Fix the negative exponent first. Now we're going to rewrite. I have 1 over. I'm going to stick a negative out there. How do I rewrite this? What does 2 become? The index. 2 becomes the index. So it's the square root of 144 to what? The third power. If this were in parentheses, what would your answer to this be? Unsolvable, no solution, because you cannot take an even root, but it's not in parentheses. It's telling you that your answer is negative. If it's in parentheses, you're talking about a negative number. If it's not in parentheses, you just stick the negative on at the end. All right, so if we simplify this a little more, I have 1 over, what is the square root of 144? And then this is cubed, and it's negative. Don't worry about working that out. You guys are going to have one that big on your quiz. You don't need to do 12 times 12 times 12. You need to understand the concept. Very, very different negative 144 than in parentheses negative 144. When it's not in parentheses, it's telling you your answer is going to be negative. Yeah.
Could you solve it if it was in parentheses?
No. Okay. Oh, like you're asking me to do it. Yeah. Sorry. If the question is, no, I'm not doing it. Say it was like this. What was it? Negative 3 over 2. All right. If it was in parentheses, you would rewrite this as 1 over negative 144 to the 3 halves, correct? Now this is saying to me 1 over, this becomes your index, right? So the square root of negative 144 to the third power. When you have a fractional exponent, whatever the denominator is of the fraction, it becomes the root.
Oh, okay.
Can you take the square root of negative 144? No. I mean, you can, but what kind of a number are you going to get? It's imaginary. So this case would be no solution. There's a major difference of if the number is without parentheses versus with parentheses. With parentheses means you are talking about that negative number. Without means you're talking about the number, and then you're multiplying it by -1 at the end. Very big difference. All right, let's do this one quickly, please. What's the problem? Radical where? In the denominator, but this is attached, right, with a plus or minus sign. So how do I get rid of the radical in the denominator? Multiply by the conjugate. What's the conjugate of 4 plus radical 3? 4 minus the square root of 3. What you do to the bottom, you do to the... Perfect. Good job, guys. Let's deal with the denominator first. Make sure our radical cancels. What is 4 times 4? 16. What is 4 times negative root 3? Minus 4 root 3. Good. What's root 3 times 4? Plus 4 root 3. And what's the square root of 3 times negative square root of 3? Minus the square root of 9. All right, what happens with my positive and negative 4 root 3's? They cancel. Great. What is the square root of 9? 3. So what do I end up with on the bottom? 13, which is exactly what we needed to happen. We wanted that radical to cancel. Perfect. Now let's FOIL the top. What is 4 times 4? 16. What is 4 times negative root 3? Minus 4 root 3. What's negative root 3 times 4? Minus 4 root 3. And then what's a negative root 3 and a negative root 3? Plus the square root of 9. What is the square root of 9? 3. So what can we combine on top? 16 and 3 is 19. And then what about right here? Negative what? 8 square root of 3. And that is it. Good job. Questions on that? All right, couple more. I feel like I've done enough of 16. Actually, I'll do it. We have time. All right, if we're going to simplify here, right? We're adding and subtracting radicals. How do you add and subtract radicals? Can I just combine those right now? No, they have to have what? The same radical. So let's go ahead and do some breaking down. I'm going to keep my 5 on the outside here. What am I going to break 27 into? 9 times 3. Perfect. What am I going to break 300 into? 100 times 3. Perfect. Why did you guys choose 103? 100's a perfect square. It's the biggest one in there. And now they both have a 3 in common, right? So let's just simplify. What is the square root of 9? And then 5 times 3 is? So I have 15 square root of 3 minus, what's the square root of 100? So minus 10 square root of 3. Can I combine these? What's my answer? 5 square root of 3. What were to happen if you got to this stage right here that I put a star next to and the radicals were not the same? That's it. You just leave it right there. You may not be able to combine everything. Not a big deal. Okay, let's not make things harder than they need to be. What's the first thing I need to do here? Distribute. Look, guys, if I distribute the 0, negative 3 to the 0 power, x to the 0 power, y to the 0 power, what does that become?
1.
Everything's just 1. Don't make that harder than it needs to be. That is not a trick question. That's just see if you're paying attention. So now we're going to distribute here. I have negative 2 squared, x squared, y squared. What's your answer? 4x squared, y squared. Anything raised to the 0 power is what? 1. Good. All right, this is easy. How do I break this down? 102, perfect. Do you guys see how I'm showing my work? So I can see your thought process. You can show me. What is the square root of 100? So then I have negative 3 times 10 is? Negative 30. What? Square root of 2. Perfect. All right, these last two are not on anything. I just made them up. So if you want to take a picture real quick, I'll do them. Then we're done. All right, a problem like this can seem overwhelming. Do not try to do too much at one time. What is the first thing we should do? Distribute. We're going to distribute that negative 2 to absolutely everything. You got to be fair, top and bottom. Take your time. I'm going to rewrite this as negative 2 to the negative 2. X to the what? Power to a power, we do what? Multiply. So 10. Y to the negative 8. Good. Z to the negative second. Over 3 to the negative 2. Why is this a little tricky? The top goes x, y, z. What does the bottom say? Y, z, x. Okay, you can leave it in that order, or you can rewrite it so they're in alphabetical. It doesn't matter. Just don't get confused with something silly like that. I'm going to go in alphabetical order. So this would be x to the what? Negative 4th. Y to the negative 2 times negative 2. 4. And then z to the what? 6th. You could leave it in the order that it was. Just make sure when you go to simplify, you don't make a silly mistake. Now, before I start to simplify, what am I going to do with my negative exponents? I'm going to move them. So I'm moving that down. I'm going to move this down. I'm going to move this up. And then my numbers switch, right? You guys with me? Okay. I'm going to do it down here so you can see. So 3 squared goes up here. Negative 2 squared goes down here. Let's do x's. What do I have in my numerator? X to the 10th and x to the 4th. What about my y's? Where are they? Both in the denominator. Y to the 4th, y to the 8th. And then where are my z's? Both happen to be in the bottom. Does anybody have any questions about what I just did? Okay. Once you get your negatives to all be positive, your problem just appears a lot easier. You don't have to worry about much. Let's simplify. What is 3 squared? 9. What is negative 2 squared? 4. Okay. So I have 9 over 4. I have same bases, and I'm multiplying. So this becomes x to the what? 14th. Good. I rewrite my y. This becomes y to the what? 12th. And then I rewrite my z's, and that becomes z to the 8th. Perfect. That problem is not hard if you guys take your time and you go step by step. If you try to do too much in one step, you're going to get yourself confused, 100%. So just take your time. Use as much space as you need. All right, this last one. Square root of 120 times the square root of 32. Guys, a house times a house is just a bigger house. Should you multiply 120 and 32 and then try to break it down? Absolutely not. Let's go ahead and break down each one individually. All right, 120. What makes up 120? Think about 12. What makes up 12? What's a perfect square that's in 120? 4 and, okay, 4 and 30. That's fine. We might be able to break down 30 later, but just to get it going. And what about 32? 16 and 2. Good. What can I make a little smaller? Okay, I can make 30 a little small. You want to go ahead and pull out square roots first if you want? What's the square root of 4? 2. What's the square root of 16? 4. So I have 2 square root of 30 times 4 square root of 2. What can I break 30 into? 15 and 2. Okay. What else could you have done 30? 6 and 5, and then broken down 6 to however you guys want to do it. So let's multiply what's on the outside. 2 times 4 is 8. And then what do we have left on the inside? 2 times 2 times 15. You guys agree? What do you notice about 2 times 2? It's 4. If you have a pair of something, remember I told you, you can take out a pair of something because what is 2 times 2? 4. What's the square root of 4? 2. So you can pull that out. So we're left with 8 times 2 is 16 times the square root of 15. Can you break down 15 anymore? No. Make sure, guys, if you need to write out all of the factors, if you need to write 30 as 2 times 3 times 5, in its most simplest form, unless you can just extrapolate, you can take out the biggest perfect square from the beginning, break down as much as you can, and just keep breaking down. All right, we're good? You guys are going to be fine. You've got to practice, though. I would rewatch this tonight. I would go through all of the practice examples that you have as far as the quiz review and stuff is concerned. If you have questions, come see me this afternoon. Come see me tomorrow morning before 7:55.